Until the late 19th century, glass in America and Europe was still made manually by skilled glassblowers. Conditions in glass factories were harsh and unpleasant, and child labor was used for unskilled tasks. However, glassblowing was difficult to automate, so glassmaking was one of the last manual trades to be industrialized. Some semi-automatic machines were developed, but the dream of fully automatic glass container production remained out of reach until the 20th century. Our story begins in 1880 in Hartford, Connecticut. Two inventors, William Hannes and William Lawrence, formed a partnership to design and build industrial machinery. One of their first projects was a machine to make paper bags. They soon moved on to glassmaking equipment. In 1912, they formed the Hartford Fairmont Company with a mission to develop automated bottle-making machines. Hartford Fairmont would become a pioneer of automation in the glass container industry and eventually take on the name Emhart Glass. Hannes and Lawrence were not the first inventors to take on the challenge of automated glassmaking. The first automated bottle-making machine had been invented in 1903 by self-taught genius Michael Owens. The Owens machine worked by sucking up molten glass into a huge rotating set of molds. It worked fairly well, and it ended the use of child labor in glass factories. However, it was cumbersome and expensive, and it still needed an operator to remove the finished wares. To create their own machine, the young inventors needed a better way to feed molten glass into molds. Inspiration comes from the most unlikely sources. One night, new recruit Carl E. Pyler was spooning honey for a bedtime snack when he noticed how the honey formed into lumps, or gobs, as it fell. Could glass be made to do the same thing? A wooden prototype was soon built, but perfecting the idea took months of painstaking work. Working by trial and error, Pyler varied glass temperature, gob weight, and other factors, filling notebook after notebook with records of his experiments. Eventually, he perfected the paddle gob feeder, which used gravity to form gobs of glass that fell neatly into molds. Just 1 year after its formation, Hartford Fairmont had achieved its first major milestone. Incredibly, the basic design of Pyler's feeder remains fundamentally unchanged. Feeders working on the same principles are still in use today, 100 years after Pyler's brainwave. In 1922, Hartford merged with the Empire Machine Company, another designer of glassmaking machines, becoming Hartford Empire. 2 years later, Hartford Empire made the single most important breakthrough of its history, the invention of the IS machine by Henry W. Ingle. IS, or individual section, used multiple modules to form glasswares with the blow and blow process. It was fast, reliable, and flexible, and operators could work on one section without stopping production. And the quality of the finished product was excellent. Keen to understand the problems faced by glass manufacturers at first hand, Hartford Empire built its own experimental glass factory, chemical lab, and optical testing lab. The tradition of understanding customers' needs has continued right up to the present day, when in 2007, Emhart opened a brand new research center in Windsor, Connecticut. During the 1920s, Hartford Fairmont expanded its expertise into new areas of the glass container production line. One of these was refractories, the heat-resistant containers in which glass is melted before being formed. As well as being supremely hard-wearing, refractories also need to ensure that the glass is evenly heated. In 1926, the firm teamed up with Corning Glassworks to form Corhart Refractories, a joint venture to design, engineer, and manufacture refractory systems. The enterprise was successful for many years before being eventually abandoned in the 1960s. Emhart's own refractory range took a major step forward in 1980 when President Ray DeVita oversaw the purchase of refractory specialists Laclede Christie, based in Owensville, Missouri. In 1983, all of Emhart's refractory manufacturing was consolidated at the Owensville facility. As part of Emhart, Owensville continues to research and develop the glass industry's widest range of expandable compositions for glass refractories, with in-house expertise enhanced with technical support from the nearby University of Missouri. The end of Prohibition in 1933 provided a huge boost for the glass container industry, as demand for drink bottles soared. By the 1940s, Hartford Empire had become a respected innovator, with a rapidly developing export business. At that time, the firm's directors realized that depending on glass could be dangerous, so they began acquiring other firms, beginning with Standard Knapp and Henry & Wright. This laid the foundations for the mighty industrial group that Emhart would later become. Before World War II, finished glassware was checked by hand. It was expensive and slow. The 1940s saw the dawn of a new era in the glass industry, with the first move toward automatic inspection. Hartford Empire launched the first automated inspection unit in 1945, and made inspection a key research priority from then on. Meanwhile, in Elmira, New York, enterprising young engineer Whitney "Bud" Powers founded Powers Manufacturing, which went on to become the leading innovator in glass container inspection. Emhart acquired Powers Manufacturing in 1982, allowing its customers to use the same firm for both glass forming and container inspection solutions, and work with a partner who truly understood every stage of their production process. In 2007, the inspection business grew once again with the acquisition of ICS Inex, based in Clearwater, Florida. 2 years later, the first fruit of the alliance appeared: Emhart Glass's revolutionary Flex Inspect system. In 1951, Hartford Empire decided that the rapidly expanding group needed a new name. Its managers struggled to think of one, until someone suggested using the company's cable address. It was simply Hartford Empire, abbreviated and in reverse, Emhart. The Emhart Manufacturing Group continued to grow by acquisition. By the 1950s, it offered a wide range of industrial machinery, as well as glassmaking machines, from seawater distillers to Skyworker overhead platforms. 1952 saw an important addition to the family, with the acquisition of veteran Swedish machinery maker Sundsvalls Verkstäder, which had originally been founded as a bell-making factory in 1756. In time, the Swedish branch became the key site for building Emhart's IS machines, a role it still plays today. The Swedish acquisitions had an important strategic background. By the 1950s, the American glass industry was maturing fast. For Emhart, growth meant expanding its horizons to a whole new world of opportunity: Europe. During the years that followed, several European sales and service centers were also set up across Europe, and a new training center was established at Sundsvall in Sweden. Thousands of customers came here to learn more about IS technology. In 1964, Emhart Manufacturing Group merged with the American Hardware Corporation. The combined group, which took the name Emhart Corporation, had more than 25 divisions and employed 11,000 people around the world. 12 years later, in 1976, Emhart Corporation sealed another major deal, merging with USM to form the new Emhart Corporation. The combined business was a billion-dollar company with interests in many different industries. As the 1970s began, IS technology continued to evolve with the invention of the automatic gob distributor, which allowed for more and more sections to be added to IS machines. The 1970s also saw the first moves toward electronic control systems. Some of the controls developed in this period are still in use today. Building on its success, Emhart opened a new manufacturing facility in Windsor, Connecticut, and set up sales offices in Japan, Singapore, and China. By 1977, over 1,000 IS machines had been built at Sundsvall. But Emhart was not content to rest on its laurels and developed Advanced IS, or AIS, which consolidated all the innovative features developed since the creation of the original IS system. The 1980s saw increasing use of electronics to control the production process, beginning a line of innovations that continues to this day. Electronics made IS production much easier to manage and more responsive to changes in demand. In 1989, Emhart Manufacturing Group was acquired by Black & Decker. The glass machinery division took on its present name, Emhart Glass. In 1998, Emhart Glass found a natural home when it became an independent division within Bucher Group, the veteran Swiss machine maker. As a new century dawned, a new technology was born. The next generation IS, or NIS machine. NIS was a traditional IS machine at heart, but used servo-electric rather than pneumatic mechanisms. It was faster, more flexible, and more economical, and brightly colored too. In the 1950s, Emhart had unlocked the next stage of its growth by expanding into Europe. As the 21st century dawned, the firm looked eastwards once again, identifying new opportunities in Asia. In 2009, an all-new facility was opened at Johor Bahru in Malaysia. 2 years later, Emhart Glass announced a major joint venture with Sanjin, one of the leading glass machinery makers in China. Today, Emhart Glass continues to lead the industry after more than a century of innovation in glass container manufacturing. From humble beginnings, the firm has become the world's leading international supplier of equipment, controls, and parts to the glass container industry. Emhart Glass is a truly global, multicultural enterprise with a worldwide network of branches serving clients of every type on every continent. But the journey is far from over. The company remains totally committed to innovation. Every day, its engineers are working tirelessly to find the next step forward, the next improvement to the glass-making process.